Hello there, Mr. Sutton here, bringing you the IM3 8-4 Extra Practice Number 1 solutions on independent and dependent events. For this problem, we're rolling a cube with the following numbers on it and also spinning a spinner which has these 6 letters on it. We want to find the probability of rolling or spinning a G and rolling a prime number. So these are going to be independent events. What you do on the cube and the spinner has nothing to do with each other. So we're just going to find them individually and then multiply them. So for G, that's one of 6 letters. So that's 6 for our denominator, the total possibilities. And it's one of 6 letters. There's only one G on this spinner. So that probability is 1 over 6. Now we're going to multiply that by the probability of rolling a prime number. For prime numbers on here, well, there's 6 numbers overall, so that's our denominator. How many of these are prime numbers? Well, 16, 18, 20, 22, 24, those are all even. They're all divisible by 2. So they're definitely not prime. The only even prime number is 2 itself. 13, though, only has 2 factors, 1 and itself. So 13 is our only prime number there. So that's going to be 1 out of 6 for a prime number. And then multiplying these, we end up with 1 over 36. On this problem, using the same situation from part A, we want the probability of rolling a 20 and spinning a K. Well, there's only one 20 out of 6, so we have 6 for the total, 1 for the desired event for rolling a 20. And then for the probability of spinning a K, again, there's 6 letters, so that's our total possibilities, and there's only one K on there. So this gets multiplied out and again comes out just like part A did to 1 over 36. For this problem, we want the probability of rolling not an even number and spinning a B or a D in this situation up here. So let's talk about rolling not an even number. So there's 6 numbers on this cube, so that's our total possibilities. And out of those 6 numbers, the only number that's not even is 13. So that's just 1 out of the 6 for that probability. Now for spinning a B or a D, we have 6 letters, so there's our total for that one. And we have, let's see, one here that's a B, here's another letter that's a D, and those are the only B's or D's on this spinner. So that's 2 out of the 6 that have what we're looking for. So before I multiply these out, let me reduce this a little bit. 2 and 6 can reduce. That's really 1 over 3. So now multiplying this out, we have a 1 in the numerator, and 6 times 3 gives us 18 in the denominator. For the next couple problems here, we have a 6-sided number cube, presumably with the numbers 1 through 6, and a spinner with the letters A through H, and that's 8 letters in case you were wondering. We want to find each probability, so our first one is rolling a 2 and spinning an A. Now, it's important to note that these events are completely independent of each other. Whatever you roll on your number cube doesn't change your outcomes for this spinner. So we can just find these probabilities separately and then multiply them together. So rolling a 2, well, we've got 6 total possible outcomes for the number cube, and a 2 is presumably just one of them, so that's 1 over 6. And then spinning an A, well, there's 8 letters from A to H if you count them out. Feel free to do your alphabet song there. So that's 8 for our total possibilities there. And only one of those letters is an A. So multiplying this out, we end up with 1 over 48. For this problem, we want the probability of rolling an even number and spinning a vowel. So let's talk about even number first. Again, there's 6 numbers on our cube, so that's our total probability. Now, out of those 6, half of them are even, 3 of them are even, 2, 4, and 6, so that's 3 out of 6 for rolling an even number. And we can reduce that later on if we need to. And now spinning a vowel, well, let's see, how many vowels are there? Well, let's start with the total possibilities first. So there's 8 letters on this spinner. And let's see, our vowels, we have A, we have E, and those are the only 2 vowels between A and H. So that's 2 for that. Let's reduce this a little, and then we'll multiply. So a lot of ways to do this, but I ended up reducing the 2 and the 6. So we have a 1 up here now and a 3 down here. And now this 3 and the 3 that we got by reducing can cancel. So when all is said and done, we end up with a 1 in the numerator and 8 in the denominator. For this problem, I want to know the probability of rolling a number less than 3 and spinning a consonant. So let's talk about less than 3. There's 6 numbers on our cube, and out of those 6, well, there's only 2 numbers that are less than 3. That would be 1 and 2, so that's a 2 out of 6 for that probability. Now for spinning a consonant, again, we have 8 letters between A and H to choose from. And how many are consonants? Well, it might be easier just to figure out how many are not consonants. Consonants are, just to review here, they're not vowels. We know there are 2 vowels between A and H. It's A and E. So that means there are 6. The other 6 letters are consonants because they're not vowels. So that's 6 out of 8. And now we can reduce this a little bit here. The 2 and the 8 can reduce to 1 over 4. And these 6's can completely cancel out. So we're left with a 1 in the numerator over 4. For the next few problems, we're being asked whether events are independent or dependent. The situation is that we've got all these marbles in a hat, and the first situation on this set of problems is that we pick a red marble followed by a marble that's not green with replacement, which is to say after we pick our first marble, we just put it back in the hat and it's available as one of the marbles that we could select on our second try. So since we're putting the marble back in the hat, we're replacing it, these are independent events. What I get on the first pick does not affect the second pick because I'm just putting the marble back and basically resetting everything. So for my probability, I need to first find my total possible outcomes. And I can get that by adding up all these marbles. So we have 5 grays, 4 reds, 5 whites. So let's see, 5 plus 4 is 9, plus 5 is 14. Plus the other 2 marbles here and over here, that's 18 total. So we're going to get something out of 18 for the probability of picking a red marble. Now there are 4 reds, that's our desirable outcomes, so we have 4 over 18 for that first probability. Now for the other probability of getting a not green marble, well again, since we put the marble back, we still have 18 total marbles to choose from. And how many of them are not green? Well, there's our 2 green marbles, so if there's 18 altogether and 2 of them are green, that means 18 minus 2 equals 16 are not green. And we're going to multiply these, but first let me reduce this. So I'm just going to reduce each fraction here. 4 over 18 reduces by 2's to give me 2 over 9. And 16 over 18 reduces to give me 8 over 9. Multiplying this out in the numerator, 2 times 8 gives me 16. And downstairs, 9 times 9 gives me 81. For this part of the problem, we're talking about picking a navy marble followed by a white one without replacement. Since we're not putting the marbles back after we select each one, what I do on the first pick is going to affect what I can do on the second pick. So these events are dependent on one another. So for my first probability, getting that navy marble, again, just like before, I'm starting out with 18 marbles, so that's my total possibilities down in the denominator. And out of those 18, 2 of them are navy, so that's 2 over 18. Now we're talking about the probability of picking a white marble given that we've already picked a navy marble. So since you already picked one of the marbles and didn't put it back, you now have 17 for your total possibilities. But the marble that you picked was a navy marble, not a white one. Since you didn't take any of the white marbles, that means you still have 5 of those for your desired outcomes. And let's reduce a little bit and then multiply. So 2 over 18, that can reduce to 1 over 9. Multiplying things out, we have a 5 in the numerator, and 9 times 17, well, let me think here. 9 times 10 is 90. 9 times 7 is 63. 90 and 63 gives us 153. For this one, we want to talk about the probability of selecting a gray marble followed by another gray marble with replacement. Since we're putting the marble back, these events are independent. What I do on the first one has nothing to do with the second one because I'm basically resetting the situation when I replace the marble. So for my probabilities, for that first gray marble, I have 18 marbles overall to choose from. And out of those 18, it says that 5 are gray. So 5 over 18 is that first probability. Now for the next probability, since I put the marble back, I again have 18 marbles to choose from. And even though the first marble I picked was gray, again I put it back. So I still have 5 gray marbles the second time around. I can't really reduce this. Multiplying it through, though, we've got 5 times 5 gives me 25 up there. And let's see, 18 times 18, I'll just do that on the calculator. So crunching those numbers, that comes out to 324. So there's my probability of picking 2 gray marbles with replacement. For this one, we're talking about picking 2 gray marbles without replacement. Since I'm not putting the marbles back, what I do with my first pick is going to affect my second pick. So these are dependent events. And now let's talk about the actual probabilities. For that first gray marble, you have 18 marbles when you start out. So that's our total possibilities. And out of those, it says that 5 are gray. So 5 over 18 is the probability of getting that first gray marble. But now how about that second gray marble? Once you've already taken a marble out of the hat without putting it back, you're down to 17 total possibilities. And we have to go a little bit further here because that first marble that you picked was gray. If you already got a gray marble, that means you no longer have 5 gray marbles to choose from. Now you're down to 4 gray marbles for that second pick. So we can actually reduce this a little bit before we multiply. The 4 and the 18 reduce to 2 over 9. And then multiplying things out, we have 5 times 2 giving me 10 in the numerator, and 9 times 17 ends up being 153 in our denominator.